Good day, everyone. Welcome to the school's orientation program, the integration of ICT tools in school instruction. You might ask the reason of this occurrence, but it intentionally created for us to still learn amidst the pandemic, specializing the resources that will make our teaching learning sessions more effective and convenient. So, with no further ado, let me now show a video presentation of an educator that uses ICT tools in his class. And let's see how he managed to make the discussion better than the traditional ones. Good day, students. Welcome to our virtual class. So, before we will proceed to our topic, let me first read to you our virtual classroom rules. So first we have, when we meet, pretend you are sitting on the carpet at school. Second, stay in one spot. Just like when we are in class, we can get up and move around. Third, we all stay on mute. If you have a question, you raise your hand. Then, don't get up and leave until our virtual class is over. And follow the conversation. Just like in class, we can share something that isn't about the topic. Then, lastly, be respectful of your friends when they ask or respond to questions. So, I hope that our virtual class rules are clear to you. So, as we proceed to our main topic, I have here a picture. By the way, class, I would like you to know that after our virtual class, I will going to give you a link for our attendance. So, I will show a picture that is related to our topic for today, and it will give you a overview or if what is it all about. So based on the picture here, so what can you say? Yes, very good. So it it shows the four fundamentals, and also we can see in the picture that it distribute to one another. Yes, very good. It is a binary operation. So, our topic for today is all about the binary operation. So, what is binary operation? But before that, let me first read to you our objectives. So, here are our objectives. First, define binary operation. Second, cooperate in the activity involving the different properties of binary operation, and lastly, understand the properties of binary operation. So now, based on the picture that I've shown earlier, what is a binary operation? Yes, very good. Actually, the four fundamentals are actually types of binary operation. So now, we're going to discuss what is a binary operation. So, a binary operation, asterisk, so asterisk represent as the binary operation. So, a binary operation asterisk on a set A is an operation which, when applied to any elements x and y of the set A, yields an element x asterisk y of A. So, let's have an example so that we could clearly understand what is a binary operation. So, here is the example. The arithmetic operations of addition, subtraction, and multiplication are binary operation. So, the addition, subtraction, and multiplication are binary operation. On the set real numbers which, when applied to real number x and y, yield the real numbers x plus y and x minus y and xy respectively. However, division is not a binary operation. So the division is not a binary operation on the set of real numbers, since the quotient of x and y is not defined when y is equals to 0. So under a binary operation, asterisk on a set must determine an element x asterisk y of the set for every pair of elements x and y of that set. So we have 4 types of binary operation. We have binary addition, binary multiplication, binary subtraction, and binary division. So I have here an example. So first example is, let us show that addition is a binary operation on real numbers and natural numbers. So we will going to show that the addition is a binary operation on real numbers and also in natural numbers. So if we add two operands which are natural numbers a and b, the result will also be a natural number. So if we will going to add two operands which are natural numbers, it will result also a natural number. The same holds good for the real numbers. So next is we have, let us show that multiplication is a binary operation. So on real numbers and also in natural numbers. So if we multiply two operands which are natural numbers, the result will also be a natural number. So it is the same in addition, binary addition. So the same holds good for real numbers. Then next we have, let us show that subtraction is a binary operation on real numbers. So if we subtract two operands which are real numbers a and b, the result will also be a real number. So if we will going to subtract a real number, it will result a real number. But the same does not hold for natural numbers. So it is not applicable for natural numbers, because if we take two natural numbers, example, we have 3 and 4 as a and b, then 3 minus 4 is equal to negative 1, which is not a natural number. We all know that negative 1 is not a natural number. So now, similarly, the division cannot be defined on real numbers. So also, a division cannot be defined on real number. This is because real numbers times real numbers is given by a and b. A divide b. Now, if we take b as 0, here, a over b is not defined. Now, we will going to proceed to our properties of binary operation. So we have 7 properties of binary operation. We have closure property, associative property, commutative property, the identity, inverse, distributivity, and last one is the cancellation. So first, we're going to discuss the closure property. So it is said that a closure property is said under a binary operation asterisk if for any two members from the set, the result of the binary operation returns a member of the set. So what is a closure property? Let's have an example. So an example, if R is the set of real numbers, then under addition, the set is closed. So if the real number, if in the set is a real number, so we're going to close the set if under the addition. Example, we have 2 plus 3 is equals to 5. So 5 is in the set and is a member of the set of real numbers because 5 is a real number. Then we have 6 plus negative 9 is equals to negative 3. And negative 3 is also a member of real numbers. So, did you get, class? Do you have any question? Okay, let's proceed. So, the second property, which is the associative property. So, let asterisk be a binary operation on a set A given any three elements x, y, and z of a set A. The binary operation applied to the elements x, asterisk y, and z of A yields an element x, asterisk y, close and open parentheses, asterisk z of A. And applied to the elements x and y, asterisk z of A yields an element to x, asterisk close and open parentheses, y, asterisk z of A. Then, a binary operation asterisk on a set A is said to be associative if the close and open parentheses of x asterisk y asterisk z is equal to x asterisk close and open parentheses y asterisk z for all elements x, y, and z of A. So, we have the example. The operations of addition and multiplication on the set R of real numbers are associative since x plus y close and open parentheses plus z is equal x plus close and open parentheses of y plus z, and x times y close and open parentheses times z is equals to x times y times z close and open parentheses for all real numbers x, y, and z. However, the operation of subtraction is not associative. So, the operation in the subtraction is not a associative. For example, we have close and open parentheses of 1 minus 2 minus 3 is equals to negative 4. So, the result of our but 1 minus 2 minus 3 close and open parentheses is equals to 2. So, the result of our operands are not the same. So, if here in associative property, if we're going to regroup our operands, it must be, the result must be the same. So, next. Note when a binary operation asterisk is associative, it is not necessary to retain the parentheses. In expression may both be written without ambiguity as x asterisk y asterisk z. So now we have the commutative binary operation. So it is said a binary operation asterisk on a set A is said to be commutative if x asterisk y is equal y asterisk x for all elements x and y of A. So, we're going to have an example so that you could understand more about this property. An example, the operations of addition and multiplication on the set real numbers are commutative since x plus y is equals y plus x, and x times y is equal y times x for all real numbers x and y. However, the operation of subtraction is not commutative since x minus y is not equal to y minus x in general. Indeed, the identity x minus y is equals y minus x holds only when x is equals to y. So, another example, 2 plus 3 is also equals to 3 plus 2. So, the result of our operands is the same. So, we can call it as commutative. Example, in multiplication, we have 3 times 2 is also equals to 2 times 3. Because 3 times 2 is equals to 6 and 2 times 3 is also equal to 6. Now we have the identity. For a binary operation asterisk, if there exists just one element A such that E asterisk A is equals to A asterisk E equals to A, where A is E and elements of R, then E is called an identity elements for the operation asterisk. Then we have an example. We must always remember that the identity elements for addition is 0 and for multiplication is 1. We're going to have an example for addition first. Example, we have 3 plus 0. The identity elements for addition is also equals to 0 plus 3 is equal to 3. Then we have for multiplication. Example, 5 times 1, and 1 is the identity elements. And also, 1 times 5 is also equals to 5. So, A inverse is an element A to the power of negative 1 is called an inverse of A under the binary operation of asterisk if A asterisk A negative to the power of negative 1 is equals to A to the power of negative 1 asterisk A is equals to E, the identity elements, where E is the key identity elements under the operation asterisk. Now, we have the example. So, for inverse elements for addition, so it is the identity elements for addition is 0 and for multiplication is 1. So, I have already mentioned it earlier. So, example, 4 plus what is the inverse elements that will result to 0. So, we have negative 4. Because if we were going to add 4 plus negative 4, the result will be the identity elements, which is 0. So 4 plus negative 4 is equals to 0. And for multiplication, so what is the inverse for 5? So the inverse for 5 is 1 over 5. So if we're going to multiply 5 times 1 over 5, it will result to 1, which is the identity elements. Now, the sixth one, the distributivity. Consider a non-empty set A and a binary operation asterisk on A. Then, the operation asterisk distributes over addition if for every A, B, C is an element of A. Example, we have left distributivity. A asterisk close and open parenthesis of B plus C is equals to, yes, we're going now to distribute. Close and open parenthesis of A asterisk B plus close and open parenthesis of A asterisk C. So, we have distribute A to the left operands are B plus C. Now, the right distributivity, we have close and open parenthesis of B plus C asterisk A. So, it is equals to close and open parenthesis of B asterisk A plus close and open parenthesis of C asterisk A. Now, the last one, we have cancellation. Consider a non-empty set A and a binary operation asterisk on A. Then the operation asterisk has the cancellation property if for every A, B, C is an element of A. So example, we have left cancellation. We have A asterisk B is equals to A asterisk E. The result is B is equals to C. So we canceled A. So we could get the result B is equals to C. Now, the right cancellation, we have B asterisk A is equals to C asterisk A. The result is B is equals to C. So, the same in the left cancellation. We canceled A so that we could get the B is equals to C. So that would be all the topic for the binary operation. So class, is there any question? Okay, very good. So now, since you don't have any question, we're going to have our activity. So I will be going to group you into 3. So this row will be the group 1. And this row will be the group 2. And the last row will be the group 3. So the group 1 will be called you are the bird group. And group 2, you are the, yes, you are, what do you want to call? Okay, you are the horse group, and group 3, you will be the, okay, you will be the cat group. So now, for your activity, provide my needs. So direction, in your group, provide at least one example of each properties of binary operation. So you will going to give or provide a example, at least one, for each properties of binary operation. So what are the properties of binary operation? Yes, Miss Patian. Very good. So the 7 properties of binary operation are closure property, associative property, commutative property, identity, inverse, the distributivity, and the last one is, very good, the cancellation. But before that, I would like to show to you our rubrics. So for you to be guided in answering your activity. So for the completion, you will get 10 if you complete the task, then 8 if to lacking of 2, then 7, 6, and so on. Then for the accuracy, 10 if all your answers are correct, 8 if 2 of your answers are incorrect, 7 if 3 of your answers are incorrect, and 6 if 6 to below is your correct answer. Then the cooperation will be if all the members cooperate in answering the activity, you will get 10 and 8, 7, 6. Then for the timeliness, you will get 10, 8, 7, and 6. So class, I will give you at least I think, okay, 10 minutes is enough for you to answer the activity. So you may now answer your activity quietly. Okay class, time is up. You may now submit your output. So, for your assignment, please study in advance about the subgroup and also the elements. Now, I will going to dismiss you, and please, I will going to send the link for your attendance, and thank you class for this day. Goodbye class. Based on the video, you can see how the teacher integrated ICT tools in his class. That includes first, the Google Meet application, where students are instructed to cooperate in an online session using their mobile phones. There are few possible disadvantages and drawbacks using internet-based platforms. Regardless, it is very useful, especially in this pandemic. Then, the next one is the PowerPoint presentation, where the details of the discussion were shown easily by only tapping through the computer or laptop he's using. It supports the visual images that probably makes the discussion more efficient and understandable. Lastly, there are links provided for the student to have their attendance, and I hope you learn out of this orientation. Thank you, students.